Alright, so chemistry classes, both pre-AP and on-level classes, are working on problem-based learning. The point of problem-based learning is to have the students do all their own research and to give them some hands-on activities that will help them learn the content. So they were just given one sample prompt. A owner brings in a dog and the dog is sick. The owner did not know what was wrong with the dog, just that there was a possibility certain chemicals may have been ingested or the dog may have drank those chemicals, and the students are the veterinary technicians working at the vet clinic. So they have their veterinarians, the head ones, the teachers who are helping them out, and the students are doing all their own research. They are doing research on what the chemicals are, what are the possible probabilities that the dog may have ate those chemicals. They're taking blood and urine and vomit and stool samples from the dog and analyzing all of those with the whole overall theme being acids and bases. So students are doing this for about a couple weeks. They have some library time, they have some hands-on time in the classroom, they have BYOD Code Green where they're allowed to use their cellular devices, they're allowed to use the scientific calculators, and they're working in partners.
Right now they are just writing down their papers?
Yes, they are formulating their data. So a specific sample, something like this, is what the data sheets might look like. The medical lab reports are coming in, and the students are trying to find which chemicals are in the danger zone. So red is dangerous, yellow is warning, and green is normal. And so the students are taking all the data that they did in the lab that you saw, as well as with the research on the computers, and putting it all together into a workable product. So what is wrong with this dog? They have to let the owner know. Once they let the owner know, they have to work on forms of treatment. And so into next week, once they find out what the problems are, they'll be working on treatment options.
Okay, they will write a report, or they will
do a final lab report at the end with multiple little sections that they're working on as they go along. So the medical reports, they have already recorded their data as well as done some research. The culminating product will be how to treat the dog in one final research paper.
All right, well, thank you, Ms. Baig.
Thank you.
Wait, what's up with these?
This is the poo.
The what?
Remember from my video? The teaching videos? We'll call it feces.
Oh.
All right.
What do we have to do, guys?
Go. All right. So here we have different laboratory samples. This would be the blood of the dog, the sick dog. This is the urine of the sick dog. This is the vomit of the sick dog. And this would be the sample of feces from the sick dog. As you can see, the sample of feces is much larger than the other ones, and that's because the dog is not feeling well at all. So, do you want to tell what's wrong with the dog?
Oh, the dog ate some a variety of chemicals, which may or not be toxic.
Okay, so what did the dog do with these chemicals?
He consumed them.
Are we sure what happened?
We're not 100% sure because the guy who was talking on the phone wasn't clear about it.
He wasn't clear about it. Did he tell you anything about the chemicals?
He just named a couple of chemicals like metal cleaner and maybe vinegar or something.
What was your first task as a veterinary technician?
Our first task was to determine whether the chemicals that the dog ingested were acidic or if they were base.
Did you know anything about acids and bases before you started this?
Not technically, but just that acid corrodes many things and bases just stays neutral.
So the pet owners actually brought in certain chemical samples and we partitioned them into different features. What did you do in task 2? What was your second task assigned to you by your boss?
Well, we were assigned to determine with litmus paper whether or not the solutions were acids or bases.
Do you want to show how the test works?
Basically, whenever you get blue litmus paper, what's it called? If it turns red, it'll be an acid. If it stays blue, it'll be a base.
We'll give you a little bit of purple and red. And what you can do is you can just drop the droppers directly into here. You can do a couple different samples. You can use different dishes for each one if you want. Do you remember what the litmus paper is for? Remember what the litmus paper is for?
Yes, it was determined. It was the key to determine which chemical was an acid or a base.
Why test them both?
Because by testing them both,
Better accuracy.
yes.
Okay, so if one gives you a positive, the other would have to give you a negative.
Yes.
Okay, why don't you show us how it works?
Okay.
Pick a chemical. Which one do you want to pick?
Let's go ahead with the. And since the paper stays blue, actually,
Okay, did you say it was what? Ammonia?
yeah, ammonia.
Okay.
That was ammonia, or yeah, that's ammonia. I got you.
Okay.
And since the paper stays blue, it means it's a base. And if you try it on the red, the red will turn blue.
Can you bring this closer to the camera so we can see? Let's see. You have to just put. Oops.
And since ammonia is a base, the red litmus paper turns a shade of blue.
Okay.
And that's how we can tell that it's a base.
Okay, so that was just to test if it was an acid or base. Then it told you I could give you even more information by giving you this type of paper. Do you want to explain what this is and how to use it?
Well, this type of paper determines the pH of a solution, and you use it the same way you use the regular litmus paper. Piece right there. And this paper can turn a variety of colors, and you compare the paper to the chart, and with the chart you'll be able to see how much pH the solution has. So this would be probably pH of 7, which would mean it is a base.
Let it set for about 30 seconds and see if it gets a little darker. 7 to me I think is very yellow. Do you see a darker tint on that maybe?
That'll probably be 8.
Okay.
It could be in the middle.
It'll be either 7 or 8.
Okay. 7 is neutral, so would you hypothesize ammonia as being neutral? No. I would definitely think it's a little closer. So letting it sit, I get a little bit of an idea there. But can you explain how to read the scale? What do the numbers mean?
Let me ask you about the pH scale. Okay, so it goes from what number to what number?
It goes from
1 to 14.
1 to 14.
It could go higher, it could go lower, just depending on your solution.
Okay, can I have a close up of that? Okay, let's see.
Well, basically, any number under 7 would indicate that the solution is an acid, and anything over 7 would indicate that it's a base. And being on 7 exactly would mean that the solution is neutral.
Okay. And what does pH stand for?
Not sure. Do you guys know what it stands for?
I wrote it
That'd be something hydrogen related or something?
Oh, it stands for potential hydrogen.
Ah, there you go. See, you knew it. It was in the back of your head. Okay, let's see. And then what did you do after that?
After that, we just recorded all of our data onto our sheets that Ms. Baig gave us. We decided that we determined whether or not the chemicals that the dog ingested were acid or bases. And after that, we're just waiting to do more.
Okay. So these are the tubes. Why do you use a larger tube for?
Because that's what's coming out the most from the dog. Basically, that's what we use. Since it's more of a larger amount, it's easier to find out from that substance.
That's just how much the dog gave.
That's the size of the sample.
Yeah, this is the size of the sample he gave. Since this is feces, this is blood, this is urine, and this is vomit.
Okay. What else do you have in those
we also
Oh,
have,
these are just different
yeah, there's
chemicals.
also beer, and then there's toilet cleaner.
It was just
What
other
is that?
chemicals that we were testing.
What is this? Toilet cleaner. Okay.
Vinegar, also stomach medicine, lemon juice, and metal cleaner. Metal cleaner.
Okay, these are your notes, and
Here we recorded the properties of acid and then the properties of bases to determine the differences between both of them. And then we also put some examples of household bases and acids, so then you can kind of understand which one's which.
so let's see. So if you eat either one, that's not gonna be good for your health. I see. It's not like
No,
one
ma'am.
is less harmful than other. No,
Yeah.
no, they're all harmful.
Yes.
Okay, and what is that over here? Yes.
Oh, I made a number line of the chemicals that I tested. As you can see, okay, so I determined which was an acid or a base, and which was weaker than the other. This may not be correct right now, because this might be neutral, but yeah, everyone makes mistakes.
Which one did you get our books from?
What chemistry is AP chemistry?
No, pre-AP.
Huh? Pre-AP? Is this the first pre-AP class that you ever take? No. So are you ready for the AP exams?
Yes.
Yes. Okay. Let's see. What else? So you also a sophomore?
Yeah.
Okay. So how do you like this class?
It's pretty easy.
What would you say to other people that are afraid of AP classes? Because
Don't turn down the challenge. I mean,
Okay.
if you're able to take AP, it'll put you ahead in your life. So if you could take AP, you might as well.
okay, good. Are you going to do any more interesting experiments anytime soon?
Not that one.
None that you know of?
Not that one.
Oh, look at you, so cute. Okay. Well, thank you so much for helping me out. Appreciate you guys. All right, bye.
Problem-based learning. Not yes. Maybe they're thinking about it.
Okay.
Do you like problem-based learning? So tell me about the work. Is it more work?
Wait, what?
Is it more work for you?
It's not more work. It's just kind of hard to comprehend it sometimes.
Is it because you're having to do a lot of the research by yourself?
Yeah.
Yeah. So you know Google says the #1 skill that they're looking for is problem solving. Is that often difficult more than just memorizing something?
I think it's valid.
But you're doing great. You're doing a fantastic job. Keep it up.
Peanut butter line.
Keep it up.
Peanut butter line.